study over a 4-year span revealed that although warehouse and storage fires accounted for only 14% of all reported fires, they were responsible for nearly 40% of the total losses. The analysis also showed that a warehouse fire occurs roughly every 22 hours, and a fire causing more than $500,000 in damage happens approximately once every 11 days. In our new video series, we will discuss designing fire sprinkler systems for storage occupancies, which is considered quite an advanced topic. In this video, we'll discuss commodity classes, the first and perhaps the most important topic when it comes to storage warehouses. There's a beautiful Persian proverb that says, "If the builder lays the first brick crooked, the wall will be crooked all the way to the sky." It means that if the foundation is wrong, everything built on it will be wrong. And the story of commodity classes in designing fire sprinkler systems for storage warehouses is exactly the same. If we mistakenly assume the wrong commodity class, our sprinkler system may fail to perform effectively during a fire, or on the other hand, the cost of the system may increase unnecessarily. That's why understanding and correctly identifying commodity classes is the foundation of storage fire protection. According to NFPA 13, the factors that affect commodity classification are the product material, the packaging, and the pallet. Product materials can be non-combustible or combustible. The product may or may not have packaging. If it does, the packaging may consist of single or multiple layer corrugated cartons, slatted wooden crates, or solid wood boxes. Additionally, the commodity can be stored on a pallet or remain unpalletized. If stored on pallets, the pallets can be made of wood, metal, or plastic. All of these factors ultimately affect the final classification. Per this standard, commodities are categorized based on their chemical heat of combustion and heat release rate into 7 different groups, classes 1 through 4 and group A, B, and C plastics. As we will see later, 2 of these classifications will drop out, leaving only 5 primary categories to be used for determining the rules for sprinkler protection. In the following sections of the video, we will define all of these classes and see how commodity components like product material, packaging, and pallets affect the classification. According to NFPA 13, a non-combustible product is considered Class 1 if it meets one of 3 criteria. First, and simplest, the product is placed directly on wood pallets. As we see here, we have non-combustible metal products stacked on a standard wooden pallet. The only thing that can burn is the pallet itself. The product adds no fuel to a potential fire. This minimal fire load is the essence of a Class 1 commodity. The second criterion involves a bit more packaging. A non-combustible product is Class 1 if it's placed in single-layer corrugated cartons. The key words here are single layer. This specific limitation on the cardboard keeps the fuel load low. This rule also gives us some flexibility. We can have single thickness cardboard dividers inside the box to separate our non-combustible items, and these cartons can be placed on a pallet or stacked directly on the floor. In all of these combinations, as long as the product inside is non-combustible and the carton is just a single layer, it remains a Class 1 commodity. Finally, the third criterion. The non-combustible product is shrink-wrapped or paper-wrapped as a unit load. A unit load simply means the items are bundled together to be handled as one piece by material handling equipment. The plastic shrink wrap or paper wrap adds a small amount of fuel, but not enough to move it to a higher hazard class. And just like with cartons, these wrapped loads can be on a pallet, or they can be placed directly on the floor. It's still a Class 1 commodity. We are stepping up the hazard scale to look at Class 2. The defining characteristic of a Class 2 commodity is that the core product is still non-combustible, like metal parts, glass, or ceramics. The reason it moves up from Class 1 to Class 2 is entirely due to an increase in the combustible packaging material. Let's look at the official definition. A Class 2 commodity is a non-combustible product housed in one of three specific types of heavier packaging, or their equivalents. The first category is slatted wooden crates. While the product inside won't burn, the wooden slats provide a significant amount of fuel and create air spaces that can actually help a fire grow. The second category is solid wood boxes. This is a step up in fuel load from a slatted crate, adding even more combustible wood to the storage array, even though the metal hardware inside remains non-combustible. The third category is multiple layered corrugated cartons. Remember, a single layer carton keeps a non-combustible product at Class 1. But once we introduce double wall, triple wall, or multiple layers of thick corrugated cardboard, the fire hazard increases enough to bump the entire load up to Class 2. To summarize, if our product won't burn but it's packed in slatted crates, solid wood boxes, or heavy multi-layer cardboard, we are dealing with a Class 2 commodity. The packaging dictates the hazard. Before we move on to Class 3 commodities, we need to take a quick detour. The definition of Class 3 involves specific rules regarding plastics, including Group C plastics, as well as limited amounts of Group A and B. To fully understand what that means, we first need to look at how NFPA 13 classifies plastics overall. Let's start with Group C plastics. Out of the three plastic groups, these present the lowest fire hazard. In fact, Group C plastics burn similarly to ordinary combustible materials like wood and paper. Next, we have Group B plastics. These materials burn with a higher heat release rate than ordinary combustibles, but they are less hazardous than Group A plastics. Finally, we look at Group A. These are the most hazardous plastics, meaning they burn the fastest and release the most heat. Group A plastics are specifically divided into two distinct categories: non-expanded, which are standard solid plastics, and expanded, which are foamed or cellular plastics like styrofoam. Expanded Group A plastics represent the highest hazard level due to their cellular structure, which traps air and significantly reduces their density. This decrease in density translates to lower thermal inertia, causing the material to heat up and burn much faster. Now that we understand how plastics are grouped by their fire hazard, we have the exact context we need. Let's jump into the definition of Class 3 commodities. A Class 3 commodity is defined as a product fashioned from wood, paper, natural fibers, or Group C plastics. Unlike Class 1 and Class 2 commodities, where the product itself is non-combustible and the fire hazard comes almost entirely from the packaging, a Class 3 product is inherently combustible. Because the product and its packaging share similar burning characteristics, the specific type of cardboard box no longer dictates the classification. Whether these wood, paper, or natural fiber items are stored completely exposed, placed in single-layer corrugated cartons, or packed in multiple-layer cartons, they remain a Class 3 hazard. These commodities can be stored with or without wooden pallets. Additionally, NFPA 13 allows a Class 3 commodity to contain up to 5% by weight of non-expanded plastic or up to 5% by volume of expanded plastic of Group A or B plastic, either as a component of the product itself or as part of its packaging. For example, as shown in this figure, the wooden toy products, along with the corrugated cartons and the wooden pallet, all fall into the Class 3 commodity category. However, the zip-top plastic bags, which are considered a non-expanded Group A plastic, may change the overall commodity class. To determine the final classification, we must calculate the weight percentage of this non-expanded plastic. Assume the total weight of the wooden pallet, cardboard boxes, wooden toys, and plastic bags combined is 200 pounds, and the total weight of just the plastic bags is 8 pounds. Since the weight percentage of the non-expanded plastic, calculated by dividing 8 by 200, is 4%, it falls safely below the 5% maximum allowance. Therefore, this specific pallet load remains within the limits and can continue to be protected as a standard Class 3 commodity. Section 2433 states that Class 3 commodities may contain a mix of Group A expanded and non-expanded plastics based on figures 2433A and B. Because this is such an important topic, let's review these figures in detail later in the video. According to NFPA 13 Section 24.4, a Class 4 commodity is defined by specific criteria heavily focused on Group A and Group B plastics, regardless of whether pallets are used. We will now examine these criteria in detail. First, if a product is constructed partially or totally of Group B plastics, it falls into Class 4. Second, Class 4 includes free-flowing Group A plastic materials. Think of small plastic pellets, powders, or flakes stored in bags or boxes. These plastics fall out of their containers during a fire, fill the flue spaces, and create a smothering effect on the fire. The rest of the Class 4 criteria deal with strict percentage allowances for Group A plastics. We remember from Class 3 that a commodity can contain up to 5% of Group A plastics. Class 4 is exactly what happens when we cross that threshold. If our product contains greater than 5% and up to 15% by weight of Group A non-expanded plastic, it gets bumped up to Class 4. This rule applies whether the product is carton, packed in a wooden container, or simply exposed. What if we are dealing with expanded Group A plastics, like styrofoam packaging? If the product is cartoned or in a wooden container and contains greater than 5% but up to 25% by volume of expanded Group A plastic, it is classified as Class 4. Just like with Class 3, NFPA 13 outlines specific situations for Class 4 where we need to refer to figures 2433A and B. We'll cover those shortly. Let's explore a fascinating nuance in NFPA 13 that often surprises people: the dual nature of the carton in a fire scenario. Depending on what is inside the unit load, the carton can act as either a fuel source or a protective shield. For commodity classes 1 and 2, we view packaging as the primary fuel. Since the product itself, like glass or metal, won't burn, the carton and the wooden pallet are the only materials feeding the fire. In these classes, heavier packaging is the specific factor that triggers a higher hazard classification. But when we transition to high hazard materials, specifically Group A plastics, the role of the carton completely flips. A carton actually reduces the overall fire hazard compared to storing that exact same plastic exposed. It comes down to fire dynamics and sprinkler interaction. Group A plastics have a massive heat release rate. If a fire starts on exposed plastics, it spreads rapidly, and the smooth plastic surfaces often shed sprinkler water, making the fire incredibly difficult to control. However, if those same plastics are inside a carton, the carton acts as a sacrificial barrier. The initial fire involves the cardboard, which burns much slower than the plastic. When the sprinklers activate, the cardboard absorbs the water. This creates a wet, soggy shield that absorbs heat, cools the package, and significantly delays the fire from reaching the volatile plastics inside. This water-absorbing mechanism is precisely why NFPA 13 imposes much stricter thresholds and higher hazard classifications for exposed plastics compared to their cartoned counterparts. It is also important to note that while we focus on the carton, this same logic applies to wooden boxes and crates. Because wood and cardboard share similar properties, both are cellulose-based materials that absorb water and shield the internal contents, they function the same way in these hazard classifications. To identify Class 3, Class 4, and Group A plastics, figures 2433A and B are excellent tools that act as a visual master key. To understand how to read these charts, let's use figure 2433B for exposed commodities as our example and look at three possible scenarios. First, consider a product containing solely expanded plastic. If it has 0% non-expanded plastic, our data point falls exactly on the horizontal x-axis. As the volume percentage of that expanded plastic increases, we simply slide to the right along the bottom line of the chart. As we move right, we can see the commodity cross the boundary directly from Class 3 into Group A non-expanded at 5% by volume, and eventually into Group A expanded once we pass the 25% mark. For our second scenario, imagine a product made only of non-expanded plastic. Because it has 0% expanded plastic, the point falls exactly on the vertical y-axis. As the weight percentage increases, we move straight up the left side of the chart. We transition from Class 3 into Class 4 at 5% by weight, and finally into Group A non-expanded when we exceed 15%. As a quick note, if we were looking at figure 2433A for carton commodities, the process is exactly the same. However, the limits are a bit higher. For instance, the transition to Group A expanded happens at 40% instead of 25% because the cardboard carton acts as a protective shield. Finally, what happens when the commodity contains a mix of both expanded and non-expanded plastics? The point will fall somewhere within the body of the diagram itself. This is where the graphs show their true value. By finding where our x and y values intersect, we can instantly see how the combination of the two plastics dictates the final classification, even if neither plastic alone was enough to push it over the threshold on the axis. Let's look at a real-world example to see how this works in practice. Imagine we are protecting a warehouse storing high-end wooden speakers. Fundamentally, solid wood is a Class 3 commodity. Our speakers are packed inside standard corrugated cardboard cartons. However, we have to account for the plastic components. The dense plastic housing for the speakers makes up 10% of the total weight. That's our non-expanded plastic. Inside the box, EPS foam corner blocks are used for protection, taking up 15% of the total volume. That's our expanded plastic. Because our commodity is cartoned, we head straight to figure 2433A. We can't just look at the wood and assume it's Class 3. We have to plot our plastic mixture. First, we look at the horizontal x-axis, which represents the volume of expanded plastic. We find our 15% mark for the foam blocks. Next, we look at the vertical y-axis for the weight of non-expanded plastic, and we find our 10% mark for the plastic housings. When we follow those two lines to their intersection, we can see exactly where our hazard falls. Our point lands clearly above the diagonal boundary line for Class 4, putting us right into the Group A non-expanded region. Even though the bulk of the product is wood, the combined fire hazard of that 10% heavy plastic and 15% foam packaging generates a heat release rate that completely exceeds the limits of Class 3 and Class 4. To ensure our sprinkler system can actually control a fire, we must protect it as a Group A non-expanded plastic. Earlier, we briefly introduced the three main types of pallets found in warehouses: wood, metal, and plastic. Now we need to understand how the pallet we choose actually impacts our final commodity classification. Let's start with the easiest one, metal pellets. Because metal is non-combustible, it doesn't add any fuel load to a fire. Therefore, storing our products on metal pallets has absolutely no effect on our commodity classification. The hazard remains exactly what the product and packaging dictate. For Class 1 through Class 4 commodities, however, plastic pallets change the game completely. To understand exactly how they impact our design for these specific classes, we first need to look at how NFPA ranks commodity classifications by fire severity. If we arrange our hazards from lowest severity to highest severity for a given storage arrangement, we get an 8-step scale that looks like this. Wood pallets are already factored into the base classification of our commodities, but plastic pallets introduce a massive concentrated fuel source right at the base of our storage array. Because of this, NFPA requires us to adjust our classification upwards on this severity scale. The standard generally divides plastic pallets into two categories: unreinforced plastic pallets and reinforced plastic pallets which contain rigid internal grids. When we store standard Class 1 through Class 4 commodities on unreinforced plastic pallets, we generally have to increase the hazard by one full class. For example, if we have a Class 3 commodity, which is step number 3, putting it on an unreinforced plastic pallet pushes it up one step, forcing us to protect it as a Class 4 commodity. However, if we use reinforced plastic pallets, the penalty is steeper because they burn hotter and maintain their structure longer during a fire. In this case, we have to increase the hazard by two full classes. This means our standard Class 3 commodity on a reinforced plastic pallet is pushed up 2 steps, bypassing Class 4 completely and forcing us to protect it as a cartoned, non-expanded plastic, step number 5 on our scale. There is one specific exception to this rule. When a Class 4 commodity is stored on a reinforced plastic pallet, instead of jumping 2 steps up to a cartoned expanded plastic, the standard dictates it is only increased to a cartoned, non-expanded Group A plastic. All of these requirements bring up a crucial practical question. How do we know if the plastic pallets in a warehouse are reinforced? These rules were expanded based on large-scale calorimeter fire testing of various plastic pallets, including polypropylene and high-density polyethylene. For many of these pallets, there is absolutely no external visual way to determine if they contain internal reinforcement. Because of this, NFPA 13 states that a pallet must be assumed to be reinforced unless it has a permanent marking or a manufacturer's certification specifically stating that it is non-reinforced. By mapping it out this way, we can clearly see that we can't just look at what's inside the box. The pallet beneath it can completely redefine the fire hazard we are trying to control. In the previous sections, we covered the fundamental rules and definitions for commodity classification. Although understanding the principles behind product materials, packaging, and pallets is essential, it's not the whole story. In Annex A, the standard provides extensive tables filled with real-world examples determined through actual testing. Let's get familiar with these tables. First, we have Table A.20.3, which is a general guide to identifying the commodity class for solid combustibles. Then there is Table A.20.4b, a highly useful alphabetical listing of hundreds of everyday products and their corresponding classes. Beyond the alphabetical list, NFPA 13 breaks examples down into dedicated tables for each specific category. What is interesting, and perhaps even confusing, about these tables is that in some cases the examples do not match the definition of each commodity class. For instance, when we look at Table A24-2, wood lumber as bundled solid blocks falls into Class 2 commodities. We know that Class 2 products are inherently non-combustible, so why does this happen? The simple answer is that fire is a complex phenomenon with many factors playing a role. Before answering this question, let's pose another one. Imagine a wooden block with a mass of 100 pounds. In your opinion, would this block burn faster as a solid block if we converted it into thin wooden sheets, or if we converted it into fine wood dust? I think you would agree that the dust burns much faster. The reason behind this is a parameter we call the surface area to mass ratio. As this ratio increases, much more oxygen gets into the fire process, and the material burns easier and faster. Now, if we go back to Table A 24.2, we can say that wood lumber as bundled solid blocks has a relatively small surface area to mass ratio. Testing shows that its fire severity and heat release rate are almost equal to non-combustible products in a slatted wooden crate or a wooden box. Therefore, it is categorized as Class 2. As another example, Table A 24.5.1 categorizes exposed tissue products as non-expanded Group A plastics. In this instance, alongside a high surface area to mass ratio, thermal inertia also plays a crucial role. Thermal inertia is the product of thermal conductivity, heat capacity, and density. As previously mentioned, materials with lower thermal inertia burn more rapidly, presenting a greater flammability hazard. Although tissue is a cellulosic material with a similar specific heat capacity to solid wood, its highly porous structure results in significantly lower density and thermal conductivity. Consequently, tissue has a much lower thermal inertia. Fire tests demonstrate that due to these properties, exposed tissue must be protected as a non-expanded Group A plastic. In conclusion, while understanding the baseline definitions of each commodity class is important, consulting the Annex tables is essential for accurate classification. The examples provided in these tables are largely derived from actual fire testing and account for complex fire dynamics parameters. Before we conclude our discussion on commodity classification, there is one final packaging factor we must address: the difference between encapsulated and wrapped commodities. In almost every warehouse, we see pallet loads secured with thin plastic stretch wrap or shrink wrap. While they might look similar at first glance, NFPA 13 makes a very important distinction based on the top of the load. If a plastic sheet or film completely encloses the sides and the top of a pallet load, this is defined as encapsulation. However, if the plastic film wraps around the sides to secure the boxes, but leaves the top completely open and exposed, it is simply considered wrapped. Why does the top matter so much? Think of encapsulation as an umbrella. If the top is sealed with plastic, water discharge from our overhead sprinklers is blocked. It cannot penetrate down into the spaces between the boxes to pre-wet the burning product. If only the sides are wrapped and the top is open, the water can still get inside the pallet load. Now, here is the crucial takeaway. Neither encapsulation nor wrapping will change our actual commodity classification. A Class 3 commodity on a wooden pallet is still classified as a Class 3 commodity, whether it is completely encapsulated in plastic or just banded around the sides. However, as we will see in upcoming videos on sprinkler system design, encapsulation changes the design criteria in many cases. Because that plastic umbrella blocks the water and allows the fire to grow larger, NFPA 13 rules will require us to step up our protection to overcome that barrier. So, identifying how a product is wrapped in the field is just as important as identifying what is inside the box.